This is what we want to build, a drill-powered go-kart. I built it with my sons on the balcony, using only basic tools and without any welding. If you want to build one too, follow along. This series gives you detailed step-by-step videos on how to design and build it yourself. This is the third video in the series, so if you haven't seen the previous one, go check them out first. In the last video we left off here. We designed the seat, the steering wheel holder, the rear axle and started working on the gearbox. And this is where we will pick up today. We will finish the gearbox, attach the drill and also mount a lever for the drill trigger to control the drive. Welcome to the video of the series how to design and build a drill-powered go-kart with your kids. Let's get started. For attaching the gearbox I used M12 screws. I intentionally used longer screws so they can also be used to tension the belt, ensuring it's tight enough and doesn't slip. Here you can see 4 M12 washers and 4 regular M12 nuts, which will be used to fasten this part of the gearbox to the baseboard. These screws will also serve another function, which I'll explain in a moment. But before that I need to design belt. Since I couldn't find it as a 3D model anywhere online, I had to draw it myself. I took both pulleys, projected them onto a plane and calculated the length of the straight section based on the total belt length, which in my case was 350 mm. Once I had the sketch ready, I just extruded the part and saved it. So back to the gearbox. Now I'll work on the other shaft, where the drill will be connected and will transfer torque to the wheel through the pulleys. I started by inserting 2 bearings with an 8 mm shaft hole. Between them I place a 15 mm wide pulley with 15 teeth. This is already the third part from whole project that needs to be modified, either by you or by a mechanist. The pulley must be drilled to an 8 mm diameter hole, and then 2 additional holes need to be drilled and tapped so the pulley can be secured to the shaft with the grab screws. I had this modification done directly by the supplier of the parts. In the order notes I just specified what needed to be done. If a technical drawing is required, it's available in the Google Drive under the name Pulley T15drawing.pdf. There is also a DWG version if needed. Speaking of Google Drive, you can find the link in the video description. Inside you will also find a complete list of all the parts required to build this go-kart. Feel free to use it. If this video is valuable for you, consider subscribing. Back to the gearbox. The shaft we will use has logically an 8 mm diameter. Most suppliers can cut it to the length you need, but it's important to leave enough extra length on one side so that a coupling can be attached. The coupling is the fourth and the last part that needs modification, and it's best to have it done by someone more experienced if you don't have the skill. All that's required is drilling an 8 mm hole through both sides, since I also used an 8 mm shaft on the other side of the coupling. I didn't make a drawing for this modification because you can simply write in the order note that you need it adjusted, and that's it. This shaft then needs to be ground down slightly so it can fit securely into the drill chuck without slipping, as shown in the video. You can do this either with metal files or with an angle grinder. Finally, the belt is placed on the pulley and this section of the gearbox is finished. Now it just needs to be connected to the remaining part of the gearbox, which I will show you next. To connect both parts of the gearbox together, I decided to use small bearings mounted on a flat steel connector plate. This connector is attached with the same screws that hold the large bearings to the baseboard. As I mentioned earlier, I intentionally used longer screws for this reason. So I drilled 12 mm holes into the steel plate, spaced to match the distance between the M12 screws. Under the plate I added a washer and a regular nut. By tightening these nuts, the belt can be tensioned properly so it won't slip. To mount the small bearing onto this plate, I measured the hole spacing and drill additional 5 mm holes. The small bearings are secured with 5 M5 screws and lock nuts. I strongly recommend using lock nuts here. I didn't, and the nut came loose. the screw fell off, and eventually the flexible coupling broke apart. With this step, the gearbox is finished and we can now connect the drill to it. The 3D model of the drill I downloaded from GrabCAD. The link is in the description. It's not exactly the same model as mine, but it's good enough for demonstration. I only slightly modified it to match the type of battery we use. The drill connects to the shaft that we previously ground down to prevent slipping. Here is how I secure the drill. First, it needs to be separated from below so it stays stable and doesn't bend the shaft. Then, I added wooden blocks on both sides to hold it in place. These 3 pieces of wood I glued to the basic board. Of course, it's possible to screw them with the wooden screws. Next, I attached a wooden plank to the steel frame of the seat so the drill's battery rests against it. I attach it with M5 screws and lock nuts. This keeps the drill from moving to the left towards the gearbox. But we also need to make sure the drill itself doesn't rotate instead of the shaft. So to fix this, I drilled holes into the side plank and into the right side of the seat frame. Then inserted threaded rods secured with the lock nuts. After measuring the spacing, I took another wooden board slightly longer than the distance, drilled matching holes and slid it over the rods. I pushed it against the drill and tightened it down with washers and wing nuts. This way, when the battery runs out, I can simply loosen the wing nuts, turn the drill slightly, remove the old battery, put it in charged one, rotate it back and secure it again. Quick and easy. To stop the drill from moving to the right, I used corner brackets with holes positioned at the back where the cooling vents are. I fix it with wing nuts as well, so the drill can be removed without tools, only with my hands. Finally, let's talk about the lever for pressing the trigger. Many designs on YouTube use a cable directly attached to the drill, but I didn't want that because I wanted to disconnect the drill easily and also avoid damaging it with the cable. Instead, here is my solution. I drilled a 5mm hole in the steel seat frame, positioned directly above the drill trigger. For the lever, I used a piece of aluminum tube with a 10mm diameter and drilled a 5mm hole through one end. Then I mounted it with an M5 screw, added a washer for smoother movement, inserted the tube from aluminum, added another washer, pushed the screw through the hole in the frame and secured it with a nut from below. Honestly, I first used a regular nut, which really fast got lost, and I never replaced it with a lock nut because the screw points downwards and doesn't fall out. That also makes it easier to remove the whole lever if I needed to take the drill out. I don't need to give away that. Thinking about it now, I realize the bottom washer is probably gone too, but it still works perfectly fine without it. Okay, so that's everything for today's video. We finished the gearbox, connected to the first part from previous video, mounted the drill, showed how I secured it to the go-kart and finally built the lever for the trigger. In the next video, we will complete the design of the entire go-kart. I will show you how I built the trunk, installed the throttle cable, designing the pedal and added a license plate. So if you don't want to miss that, don't forget to subscribe. If you like this video, you know what you can do. But most importantly, spend time with your kids building stuff.